We are language technologists at OUP, and we're going to tell you about a proof of concept that we've been working on to rethink our approach to lexical data in order that we can leverage the benefits of semantic web technologies. So many of you will know Oxford University Press as a publisher of dictionaries, but we are also a licensing partner for lexical data. In the recent past, we've been increasing our offering by licensing in foreign language dictionaries from other publishers, converting those into our data model, and then licensing them on to tech companies and other customers for language-based applications. It's in this capacity that we have been experiencing some shifts in publishing towards new trends and demands, emerging technologies and markets, all of which for us underscore the importance of semantically rich, well-structured data. In an effort to adapt to this changing landscape, we have undertaken a pilot project to remodel our lexical data, build some new processes and workflows, and hopefully equip ourselves with the agility, flexibility, and speed necessary to compete. So our current dictionary data models are represented in XML DTDs. These were designed years ago to capture a dictionary entry as it appears on a printed page. Over time, we've had to expand and loosen these data structures in order to accommodate a number of different dictionary texts, and this has come at a cost. The models now admit variation, which can become an implementation blocker for people looking to automatically process the data quickly. And so while these models are good for capturing formatting intricacies of complicated dictionary entry, they're not quite semantic enough to give us the flexibility that we need. So, gathering requirements for a new model. We need something that will represent language concepts and not a print layout. A model that will enable us to reuse our data for different products and services. And a model that only allows one clear way to represent a given lexical item. This last point is really important for us because the print-focused models that we've been using leave a little room for interpretation, and variation creeps in, and we've got the same thing marked up in 2-3 different ways sometimes.
How does that mesh with your previous point about flexibility?
I'm sorry?
How does that mesh with your previous point about flexibility, having to be more permissive? I mean, it sounds like those two things are fighting with each other.
Well, they're fighting with each other because of the orientation of the DTDs. What they're trying to do is allow for any given layout on a printed page. And what we find is that in order for us to have flexibility in using the data, we don't want to capture a print layout. We want to describe the content as it is. And only when we have a semantic model like that can we do whatever we want with the data. Does that answer your question?
I think so.
Right. So, we set to designing and came up with what we're calling the lexical schema. This is a language agnostic model. It supports monolingual, bilingual, multilingual content. It's modular, which facilitates maintenance and customization. If a particular language family has a set of requirements, we can build a separate module for that rather than having to incorporate those requirements into the data model as a whole. Key metadata comes from controlled vocabularies, and we've also embedded schematron rules to tighten things up as much as we possibly can. So now that we have this model, Sandro's going to tell you a bit about how we move some of our data into it.
I'm just checking if you can hear me at the back, as I haven't got the microphone. I'll try to project my voice. As Matt said, once we devise the lexical schema, so our new data model, then we have to think about the conversion framework to move our data into this new lexical data model. We're not just talking about one single data set, but we're talking about, as it currently is at Oxford University Press, about 40 different data sets, multiple languages spanning from Chinese to Spanish, Italian to Korean, and this can grow simply, very easily with new licensing partners. So we need to really build scalability into our conversion framework since the very beginning. Another important business requirement was standardization. As Matt explained you before, because of our process and our DTD being very permissive, also our workflow, basically working with lots of different freelancers that might have a slightly different interpretation of the DTD, then we ended up with all these sorts of variation. And we want to standardize this variation into one optimal way. I'll show you where this actually standardization step fits then in the conversion process. But this was also one of the big business requirements we had to harmonize variation. And then another thing which is important from the very beginning is the modularity. So we need to be able, in order to answer quickly to customer requests, we need to be able to customize our data sets according to the needs of our customers, but also to our changing internal business processes. These are the tools, the technical things that we picked up in order to address the business requirement that I showed you, business and technical requirement that I showed you in the slide before. We did use XProc an XProc pipeline to address the modularity and of the business requirement of modularity, because we could easily then simply slot in or out a specific step that we wanted for a specific language or even possibly for a specific customer. We did use XSpec for unit testing, and this is also something that we moved into a more unit testing development framework, whereas before, QA was basically done mainly at the end. So we wanted to build in the part of the testing that we are doing during the development phase. And so we are using, so we moved from DTD to XML schema, so we could take advantage of XML schema for that. And then we are using schematron rules, specific schematron rules. We expanded the schematron rules that we had for the legacy data model. We are using the Jenkins continuous integration server. This addresses the testing so that we can simply build in this testing into the build process for creating these data sets. And it makes also the whole process, we can simply pass parameters and then create a customizable build for a specific customer language. So again, modularity, really good for that. And then last but not least, we use an agile methodology for working. We were a team of 5 developers with then other contributors, editorial contributors, or linguists coming in for QA. So we used a version of Scrum, if you want, to basically share the workload and also adapt to changing requirements while we were converting these data sets. I'm going to give you a short overview of the XProc pipeline. This is just an example of a simplified XProc pipeline, just to show you the different steps where they occur in our workflow. So we started with our legacy data, a print-oriented XML. This is an example just for the Spanish monolingual dictionary. Then we apply a bunch of XSLT, basically, which are doing all different sorts of things. What we do at this stage here is really the standardization steps that I mentioned before, harmonizing things into one optimal single model. And we then apply schematron validation, just to check that everything is in order. And then we produce an intermediate file here. This is still valid according to our old DTD. So why do we do this? This is because we are working in a business environment where we still have customers that are dealing with our data set, our DTD. We still have to serve those customers who are perfectly happy with that, and they can work with it. But at the same time, we want to move forward lexical data. So here there is really a big business requirement, still serving your customers while innovating, going forward. So this is just an intermediate step in our pipeline, just to store this file somewhere. And this is a sort of standardized data which allows us also to hide up our legacy data model and having things with fewer variation. Then we continue, and this is where we depart from our old DTD into the XML schema, into the lexical and semantic data model. And this is also where we apply also lots of metadata, typically putting metadata in English. We are dealing with a Spanish dictionary, which might have metadata in Spanish. This is where we also put additional metadata in English. And if you think of this for other languages as well, this is why we could have picked up any language really, but just used English because it was easier for us and then required by our customers. And then we finally just apply, as usual, the schematron validation, and then we plug in also the XML schema validation, which with a nice report at the end. And we end up with our conversion of our lexical data. So this is basically the export pipeline. Most of the work is done by the pipeline. We then implemented the pipeline inside the Jenkins continuous integration server. And this is where we basically develop really a conversion framework where we plug in simply any data set in any language, any dictionary in any language, and then this conversion framework will spits out the lexical data, our new data format, data in the new data format. Basically, the Jenkins build, what it does is simply it runs a bunch of expect unit tests from the beginning. Well, first of all, it checks out the code from Subversion. Then it will apply all these tests, and then we've got a nice report at the end. It runs the XProc pipeline. Interesting part here is also that we started with a sort of monolithic XProc pipeline where we're basically putting in, or do this for Spanish, do this for Chinese and so on. We then realized that we could actually do it in a more flexible way, basically just creating the XProc pipeline on the fly in the Jenkins build. So we basically have a sort of a boilerplate, XProc pipeline boilerplate, and then we have simply a list of steps, an XML file with a list of steps for that language. So that the XProc pipeline, instead of maintaining a monolithic, huge pipeline for every single language, we just create it on the fly based on a boilerplate and list of steps. Then we do apply what we call the linguistic QA. This is actually the only manual process that we perform. Why do we do this? Because we realize that when we are converting this data, especially for languages that we have absolutely no knowledge in alphabets that we're not familiar with, as I said, we're talking about Chinese, Korean, Russian, and the European languages, whatever it will come next. So we need the help of a linguist just to make sure that the data in our in our legacy data format, during the conversion transformation, we didn't basically change the data in a way that the dictionary doesn't make sense anymore, or that we coded things in a wrong way from a linguistic point of view. Luckily, this step happens only once. So it's normally we go through this iteration process, especially for the code, but the linguistic in QA it's done only once.
So do you just sample some entries and just check if they're okay, or what's the process?
We do in our the way we did it in a team. We first started with a sample, typically the first letter of a dictionary, letter A or whatever the first letter would. So we start with a conversion of the sample, which is a small data set. Then, and this is we deliver first to our customers as well a sample to show how the data will be. Then we do the same process for the full data. So here we are converting the full dictionary. And we are applying this linguistic step for the sample first and then for the full data.
So you've got a person reading the whole dictionary?
No,
Okay.
this wouldn't be possible.
No, that's
So
right.
this is why we try to implement as much as unit tests, schematron rules, in order to automatically pick that. What we give to our linguist is a selection of these entries, typically entries, very long entries, very small entries, entries with lots of features like the verb to be, for instance, which is always very complex in languages. So it's a selection of, and this is why the linguistic QA is a human activity, so it's error prone as well, and we are aware of this. But we still need humans to check languages that we have absolutely no knowledge. But we try to automate as much as possible, and this is where the reason why we decided to implement basically testing since the very beginning. The last part of the build is basically when everything goes build is successful, we basically target the release in our version control system and then archive it typically in a zip file.
Okay, so when we license these foreign language data sets in from other publishers, they always come in a different format. Sometimes it's SQL, sometimes it's Excel, sometimes Word, sometimes plain text, InDesign, FrameMaker. Being part of the project has been like a crash course in the history of publishing technology. So we chose an XML example to keep things simple. This is from an excerpt from a Spanish monolingual dictionary. We licensed a couple of years ago. As you can see, it's in the partner publisher's data model. So there's Spanish language elements, element names, and attributes. This is a sense of the word mala uva, which is like bad egg in English. It's got a straightforward sentence wrapper with the definition, synonym, and a couple of labels expressing the appropriate region and register. All right. So when we licensed this originally, we converted it into our print-focused DTD, and we traded the Spanish language element names and attributes for publishing and lexicographical abbreviations. Otherwise, it's pretty much the same. So then when we move into the lexical data format, straight away you can see that the naming conventions are a bit more user-friendly. You'll also notice that now what's effectively metadata for that sense, what's telling you that in the previous data model that this usage of the word is particular to Spain and to the colloquial register. As Sandro said before, we've curated some mapping tables of translations for this information. We're doing this for every data set, every language that we move into the model. That way we know, regardless of the language the content is in, which senses are informal, vulgar, which ones are appropriate to this region or that. This improves searchability across all of our data.
Once we converted then the data into the new lexical data model through the conversion framework, it's basically the point where we are at the moment, and we are then planning to scale up and then to what to do with this data now. And this is where we start in basically the next slides that you will see. We're talking about prototypes and proof of concept that we have developed so far. Everything before is business, basically. Now we are trying to do something on top of that. First of all, we want to consolidate all these data sets into an XML database and possibly then use APIs on that. We want to build an RDF layer on top of the XML database in order to start using semantic web technologies to manage our data. This is an example of serialization from XML into RDF that we tried on a prototype, again on the Spanish dictionary. There are two things probably I just want to flag here. First of all, you've seen before this register labels like informal, colloquial. They are now mapped to an ontology. So we build up an ontology with all this different register, and same for region. And the good advantage of using an ontology here is that it refers to a target, a unique URI, but also we can use the ontology, well, the structure of the ontology in order then to apply maybe later on inference. Typically for region, we might have a class Spanish, but then we can have subclasses where Spanish from Spain, or Mexican Spanish, or South American Spanish, and we can then apply this inference mechanism just by the way the ontology is built. And the other change is the synonym. So in the previous slide, we show you simple synonym tag into a synonym element. In here, the synonym becomes basically a link towards the head word, the lemma, or that is describing that synonym. So we are creating automatically links in our data. This is an example, a visualization of the results of a Sparkle query applied on the English monolingual dictionary and then the English-Spanish dictionary. We are extracting here via Sparkle the senses, so the meaning of the word, in English that are in the domain of music, and we are extracting also their synonyms in English, together along with their translation into Spanish. And this is how we are able to create a sort of a network of data. The advantage of using this approach is that we can extract automatically and pretty easily using Sparkle multilingual, multi-source data sets, customized data sets. We do have customers that they want a list of all the legal terms in specific languages. So we could do this much more easily in RDF than in XML.
How do you deal with overlapping meanings? I mean, meanings where they don't exactly match, but they sort of got an area in the middle that does account.
We did apply, if you go back to the previous slide, this process proved to work quite well, but we did a sort of a benchmarking in terms of meaning, so we also asked then linguists to look at this. And we realized that there were some links which were automatically correct, other which were not that correct, and other that were plainly wrong. So we started applying some scores on this. So based on some criteria and on some links in our data, we could say that that sort of link, typically a link going from a head word into another head word, is pretty good, because we've got the bilingual dictionary also making the link, so we can prove it very easily with that. True senses, it could be a bit more complicated. So this is why we apply basically a score, saying, okay, this is 90% true, this is 80% true. The advantage is that we can then assume that those that are 90 something true, they probably don't need to be checked by an editor. Those which are beyond a certain threshold, they need some editors or some linguists to check. And this is another example of semantic web technologies that can help us to add new data and things that we could not do simply with plain XML. So it's this inference mechanism. So let's say that in our data we've got basically a word sense. Again, sense is just a meaning of a word. This sense has an antonym in another sense, and then this sense Y has a synonym in a sense Z. So all these three pieces of data are present in our XML. What is not present is actually this, that we can actually link that word sense Z with a property antonym into a word sense X. And we do this by using either a reasoner, so we plug in a reasoner, and then we start creating this new additional data. Or we also realize that for some complex query, typically on properties, it might be more useful to use a rule language like Squirrel. So we are prototyping these sort of things for basically adding and enhancing our data and saying things which were not explicitly present in the original data. So we reached the end of our presentation, and what we hope we have managed to tell you is basically how we are moving from a product-based environment into a service-based environment. So what we want to do in the future is not just to give you dictionaries and the best dictionaries in the world, but also to give you language services on top of that. And we want to, you've seen this in the technical part, that we still have to maintain a bunch of customers who are working with our data, our legacy data. And by using this approach, this conversion framework, we hope we showed you that we can actually keep the current business while innovating at the same time. We hope we showed you that the data model, the departure that we did from the data model from again, a print focus into a content-driven and semantically rich, more machine-interpretable model. And then finally, we automated as much as possible the whole conversion framework in order to fulfill our business requirements, present and future, that we might not know, and then deliver data faster and at a lower cost. Okay, thank you.
We have time for one or two questions.
So one question, I really shortly answer. One question would be, you showed that we infer some of the additional information at the RGF level, right? Yes, the antonym. Do you bring that information back into the XML model somehow? Or you just keep it, as in some other form?
That's a very interesting question, because what do we do with this data? Of course, we can sort of serialize back into XML, but this inference process actually could generate an awful lot of data, and we are also aware of the cost in terms of speed or in terms of simply processing this data. Doing a Spark query, typically with inference, it might be very cost effective. Actually, could cost a lot. So it would be actually a good business case to put the RDF back into XML. We might not do it for everything, so this is why we might want to concentrate on specific linguistic features like antonyms, synonyms, headwords, part of speech. So we might
mark that back to the XML as automatically generate so you know that is generated.
Yeah. Another thing that we want to do, here we are again thinking about the future, is also to do some crowdsourcing on the data, so that this is, just ideas that we are developing. But then we've got also to keep in mind that the data generated through crowdsourcing is not edited by an editor. So we need to keep in mind that. So we might want to keep that separate in a sort of a different layer. And this also is a question: do we want to put then back this data into XML if it's not edited by an editor, for instance? So I don't have an answer to your questions, but I have more questions to what you asked.
All right. Thanks very much.
Thank you.
Thank you.